probability space carries all possible outcomes and their likelihoods. When a state is absorbing, entering it is permanent. The process can never leave. This is not a boundary condition or an approximation. It is built into the transition structure of the process. Absorption is irreversible. Understanding this is the foundation of the entire episode. The absorption time is the first moment the process enters the absorbing set. Before that moment, the process is still active. After that moment, nothing changes. This creates a clean partition at every time t. Paths that have been absorbed, and paths that have not. Survival means the process is still in the second group. Conditioning on survival creates a new probability measure. This measure assigns 0 to absorbed paths and redistributes all weight among those that remain. As time increases, the survival probability falls. The denominator shrinks. The mass concentrates on fewer and fewer paths. This is a change of the mathematical object, not a correction of a measurement error. When the absorbing value is 0, the conditional expectation is always above the unconditional one. Absorbed paths pull the unconditional average downward. Conditioning removes those paths entirely. Only the higher value survivors contribute to the conditional average. The law of total expectation makes this exact. The unconditional mean equals the conditional mean times the survival probability. The inequality is structural, not an approximation. Taking the limit outside the conditional expectation gives a different result than taking it inside. This is not a coincidence. The conditioning event itself changes as t increases. You are not conditioning on the same thing at each step. The standard theorem for exchanging limits does not apply here. Behavior at large tt cannot be read off from behavior at moderate t. The operators genuinely do not commute. In the gambler's ruin, absorption is certain for every path. Yet the conditional expectation among survivors rises toward the upper barrier. This apparent upward drift is pure selection. In a branching process with mean offspring below 1, extinction is certain in the long run. Yet the conditional expectation among surviving lineages grows without bound. In both cases, conditioning describes survivors, not the population. Conditioning on survival is not the same as survival itself. The conditioned expectation can grow even as fewer paths survive. Quasi-stationarity describes the shape of the surviving population. It does not mean absorption has stopped. The inequality holds. Conditional expectation is above unconditional expectation. But that inequality is about the selected subset, not about the underlying process.